Hello everybody from sunny Northern California. Unfortunately, I cannot present this talk in person because of COVID-19 restrictions on travel from the United States to Europe. I'll try and do my best. Since most of you, in fact all of you, do not know me, a few words about myself. I have a doctorate or a PhD from Columbia University in New York in seismology in geophysics. But after retiring, I got interested in cosmology, especially trying to compare modern day standard cosmology to ancient Hindu or Vedic cosmology and try and find answers to some of the questions that still persist. And today's talk is going to be about dark matter. The existence of dark matter was postulated almost 100 years ago. But despite decades of efforts and an extensive experimental program, dark matter remains elusive. The question is why? The problem is we don't know what we are looking for. And we may be looking for the wrong particle. I submit that Vedic cosmology, expounded by ancient Hindu Brahmins learned in the Vedas, the oldest known books to mankind, some few thousand years ago, can shed light on the characteristics of dark matter, its relationship to ordinary matter, and its role in the evolution of the universe. But why should any self-respecting scientist, yourself or myself, even give a dime as to what these ancient Hindus thought about how the universe came into being? There are compelling evidence, and I'm going to show you some of it, that Vedic cosmology predicts, indicates, or describes a number of characteristics of the universe that are astonishingly in agreement with modern day science, models, or standard cosmology. I'm going to talk to you about today comes from Vishnu Purana. Vishnu Purana is one of 18 volumes or Puranas of ancient times describing the genealogy, geography, history, legends, as well as cosmology. And Vishnu Purana is one of the finest. It was translated into English by an Englishman, Horace Wilson, in 1840. So we can be certain that he was not, in his translation, influenced by today's notion about modern day cosmology. That much is clear, right? So Vishnu Purana, I have a quotation from Carl Sagan, the late renowned astrophysicist. He said in 1980, "It is the only religion," meaning the Hindu religion, "in which the timescales correspond, no doubt, by accident," he thought it was an accident, "to those of modern scientific cosmology. Its cycles run from our ordinary day and night to a day and night of Brahma, 8.64 billion years long, longer than the age of the earth or the sun, and about half the time since the Big Bang." It's mind-boggling that few thousand years ago, these Hindu Brahmins thought in terms of billions and trillions of years, mind you, where much of us, much of humanity, thought that the earth was only 6,000 years old. Incidentally, it turns out the 8.64 billion years cosmic cycle noted by Carl Sagan is not an accident. It corresponds, in fact, to the useful lifespan of the sun, comparable to the 10 billion year lifespan on the main sequence. But the 10 billion year number that we have and is almost universally accepted and used suffers from large uncertainties. In my opinion, roughly 2 billion years. For example, we know that the sun's luminosity increases with time as it grows older, whereas the 10 billion number is based on a steady state. So if you make a correction using, for example, the Schroeder and Smith model of 2008, the time of 10 billion time reduces to 8.9 billion years, much closer to the 8.64 billion years of the Vedic cosmology. But more importantly, that's just a detail. I think more importantly, the Vishnu Purana describes the history of this cycle. This cycle is broken up into two parts, each 4.32 billion years long. During the first cycle, life prospers, evolves, prospers, and during the second part of the cycle, life slowly disappears, ending with the incineration of the earth. And so we can use this history. It tells us, the Vishnu Purana tells us, that this cycle, which presumably began with the formation of the current sun, roughly about 4.57 billion years ago, was preceded by one cycle. And they do name each part of this previous cycle. So if you add 4.57 billion to 8.64, you get 13.2 billion years. And if you add another half to it, you will get roughly about 17 point something. Right. So the age of the universe, according to the Vedic cosmology, is between 13.2 to about roughly 17 billion years. More importantly, or equally importantly, it's Vishnu Puranas tells us that a solar system formed in the Milky Way roughly about 13.2 billion years ago, which implies that the Milky Way has to be also older than 13.2 billion years. And we know from very recently, 2018, that a small star was found in the Milky Way dating back to 13.5 billion years. Again, there is this excellent correspondence between the age of the Milky Way expounded in the Vishnu Purana and what we know of it today from current science. In fact, NASA confirmed the existence of approximately 13 billion year old solar system in the Milky Way. It was first discovered in 2003, but in 2017, NASA confirmed its existence. Next, we are roughly halfway through Brahma's cycle of 8.64 billion years, and so is the Sun on its main sequence. And the Vishnu Purana predicts that in the next 4 to 5 billion years, the Earth will be incinerated by the Sun, preceded by evaporation of oceans and a greenhouse effect. This sequence of events is amazingly in agreement with the predictions of the Schroeder and Smith model on the evolution of the Sun and its effects on the Earth. They too predict that eventually the Earth will be incinerated, and it will be preceded by the boiling over of the oceans and a wet and dry greenhouse effect. In fact, you can see on the screen the actual quotations from the Vishnu Purana on the sequence of events and the incineration of the Earth, given here in black, and at the bottom under the blue, what the model predicts. I'll give you a second to read both quotations. If you read it, it says the seas, rivers, mountain, torrents and springs are all exhaled, and so are the regions of Patala, the regions below the earth. Thus fed through his intervention with abundant moisture, the 7 solar rays dilate to 7 suns, whose radiance glows above, below and on every side, and sets the 3 worlds and Patala on fire. The three worlds consumed by these suns become rugged and deformed throughout the whole extent of their mountains, rivers, and seas, and the earth, bare of verdure and destitute of moisture, alone remains, resembling in appearance to the back of a tortoise. The great fire, when it has burnt all the divisions of Patala, proceeds to the earth and consumes it also. This is from Vishnu Purana and its quotation. Now look at what the Shorten and Smith model says. In about 1 billion years, the water vapor content of the atmosphere will increase substantially, and the oceans will start to evaporate, according to Kesting. An initially moist greenhouse effect will cause runaway evaporation until the oceans have boiled dry. The subsequent dry greenhouse phase will raise the surface temperature significantly faster than would be expected from a very simple black body assumption. And the ultimate fate of the earth, if it survives at all, would be to become a molten remnant which resembles the back of a tortoise. But eventually the earth is incinerated along with Mercury and Venus in the Schroeder and Smith model. Now, this agreement cannot be simply fortuitous. Both the agreement, the only difference is that in the Schroeder and Smith model, the incineration of the earth is in roughly about 7.5 billion years. Whereas according to the Vishnu Purana, it is in the next 4 or 5 billion years. And as I noted earlier, that the 10 billion year lifespan of the sun on the main sequence suffers from an uncertainty of about 2 billion years. And if you take into account that uncertainty, the quantitative correspondence between the two predictions is extremely good. So not only quantitatively, but also qualitatively in terms of the descriptions. And here comes the crux. The constituents of the universe. The Vishnu Purana or Vedic Cosmology tells us that the universe consists of 3 constituents, of which 2 are invisible or dark, and 1 is visible. And what does the standard cosmology tell us? It tells us the same thing, that it consists of ordinary matter or visible matter, dark matter or invisible matter, and dark energy. So in standard cosmology you have 3 constituents, 2 of which are dark. In Vedic cosmology you have 3 constituents, 2 of which are dark. Another thing to notice, that in both cosmology, these 3 constituents are not in equal proportion. Vishnu Purana tells us in their due proportion, meaning unequal. And we know from standard cosmology that ordinary matter, and dark energy are in unequal proportions. Here you can see on the screen the different names of these substances or elements or constituents in Sanskrit. Vyakta, which is visible substance and matter; Pradhana, invisible primary matter; and Purusha or spirit, invisible in non-descript spiritual energy. On the next slide, Vishnu Purana describes Pradhana or dark matter. It states that Pradhana or dark, let's leave dark matter at the moment. Pradhana is subtle, uniform, durable, self-sustained, illimitable, undecaying and stable, devoid of sound or touch, and possessing neither color nor form. Therefore, Pradhana of VC is invisible, VC Vedic Cosmology, or does not emit or absorb light or other electromagnetic radiation, just as dark matter. Is limitless and hence much more abundant than visible matter as dark matter is inferred to be, and durable and stable as dark matter is thought to be. Furthermore, VP describes the morphology and constituents of an incipient structure inferred to be a proto-galaxy. It is shaped like a coconut, rounded or elliptical as most galaxies are known to be, with a large central cavity, black hole, pulp made of Vyakta or visible or ordinary matter, surrounded by husk and made up of primary invisible matter, halo of dark matter. Here is it. On this side you can see the actual quotation. I'm not going to read it, it's rather lengthy, but you can see it in the paper, the published part of the paper. It describes this particular structure that clearly resembles a proto-galaxy, both in its morphology and its constituents. In its morphology, as I said before, it resembles a coconut, rounded or elliptical, with pulp made of visible matter and surrounded by dark matter or Pradhana, invisible matter. It's reasonable to conclude that Pradhana, or the primary matter of Vedic cosmology, is indeed dark matter of the standard cosmology. Unfortunately, Purusha, or the non-descript, invisible energy, is not described in the Vishnu Purana in similar details as dark matter or Pradhana. But here I'm going to equate it with dark energy. Simple fact that because of the other correspondences and because of the fact that the universe in both cosmology consists of three constituents, two of which are invisible. Now this slide shows you a resume of the similarities between Vedic and standard cosmology. It includes the age of the universe, the age of the Milky Way, the existence of a primeval solar system in the Milky Way, the useful lifespan of the sun, the incineration of the sun preceded by, evaporation of the oceans, greenhouse effect, and so forth, the constituents of the universe, the morphology of a proto-galaxy, and the description of the primary dark matter. So there are all these correspondences between the two cosmologies. It is unlikely that these number of correspondences are just accidental. If we accept that, then the hypothesis that yes, Vedic cosmology may in fact inform us on the characteristics and the role of dark matter in the evolution of the universe, then we can draw the following conclusions. So before we look at the implications of Vedic cosmology on the search for dark matter particle, let's look first at some of the principal tenets of Vedic cosmology. In Vedic cosmology, the universe is cyclic, and time is without a beginning, and its end is not known. It's not infinite, but it's not known. And here is a quotation from the Vishnu Purana. The deity, and remember that in the Vishnu Purana, time is deified, or if you like, is personified as a deity. So here it is. The deity as time is without beginning, and his end is not known. From him the revolutions of creation, continuance and dissolution intermittently succeed. Clearly, cyclic, time without a beginning, and its end is not known. Second, nothing except Pradhana or dark matter and Purusha slash dark energy existed at the beginning of the current cycle. The quotation: there was neither day or night, nor sky, nor earth, nor darkness, nor light, nor any other thing save only one inapprehensible by intellect or by the senses, or that which is Brahma and Puman, which is spirit, which means dark energy, and Pradhana, meaning the primary matter or dark matter. So, at the beginning of the cycle, Vedic cosmology tells us that visible substance did not exist. Only dark matter and dark energy existed. Hence, at the initial condition, the universe, space exists in perpetuity, was completely dark. And here is the most important quotation and its interpretation as to the role of dark matter on the evolution of the universe. Ordinary matter is a product of dark matter created at the beginning of a cycle and converted back to dark matter by the end of the cycle. And the quotation: the chief principle, it's also called the chief principle. Vedic cosmology or the Vishnu Purana uses a number of terms to describe the same matter. The chief principle, Pradhana, meaning dark matter, is the mother of the world, without beginning, and that into which all that is produced is resolved, meaning that all the visible matter that is produced is turned back into dark matter. By that principle, all things were invested in the period subsequent to the last dissolution of the universe and prior to creation. So we come back to the beginning of the universe. Nothing existed except dark matter and dark energy. What are then the implications for the search of dark matter? We can conclude, whether we like it or not, that according to Vedic cosmology, dark matter is not a subatomic elementary particle. The hypothetical dark matter particle should be massive, with a mass exceeding the sum of the masses of all elementary particles. Simply because, if ordinary matter or visible matter is a product of dark matter, the hypothetical dark matter, has to be more massive than the mass of all the elementary particles. Which implies, like light hypothetical particles such as axions are unlikely candidates. Also, unfortunately, another conclusion is that high energy collisions of protons in LHC, the Large Hadron Collider, are unlikely to produce dark matter particles, because these collisions produced elementary particles, and since dark matter particle is hypothetically a sum of all these particles, it's unlikely that the collisions of protons would produce a dark matter particle. Also, since dark matter is stable and undecaying according to Vedic cosmology, experiments seeking to detect the effects of products of decay or annihilation of dark matter are unlikely to succeed. And thus far, we haven't succeeded. Lastly, under certain unspecified conditions, we don't know what those conditions are, Vedic cosmology implies that ordinary matter can be synthesized into dark matter. I'm going to restate or state some of the basic principles governing the universe in Vedic cosmology. I think it's important to lay this clearly, and these are the following principles. As I said before, time is without a beginning and its end is not known. Space is unbounded and exists in perpetuity. So it's not created. It doesn't come into being in the Big Bang. The universe is a closed system. Conservation of mass and energy. Nothing is created, nothing is destroyed. One type of matter is converted into another type of matter. Dark energy and dark matter are constants from one cycle to another. The density of dark energy is constant in both space and time. The density of dark matter is virtually constant in time. Not exactly, but virtually constant, but may vary in space, and it does vary in space. Ordinary matter and radiation are created at the onset of each cycle. The densities of ordinary matter and radiation vary with time and space. Now the proposition that the density of dark matter is virtually constant in time has a number of implications. First, it resolves the cosmological coincidence problem. You know what that problem is. We don't understand why the density of dark matter is comparable to that of dark energy at the present time if dark matter came into being at the time of the Big Bang, and its density has been decreasing ever since. In Vedic cosmology, the two densities are constant in time and therefore comparable. It also explains why dark matter is much more abundant than ordinary matter, which the standard cosmology has no explanation for. Both dark matter and ordinary matter in standard cosmology are born in the Big Bang or at the time of the Big Bang, and both decrease in density. But why is it that the density of dark matter is much greater than the density of ordinary matter? Or in other words, why is dark matter much more abundant in the universe than ordinary matter? Vedic cosmology explains, because ordinary matter is a byproduct of dark matter, and only a small amount of dark matter is converted into ordinary matter at the beginning of each cycle. As I said before, Vedic cosmology, the fact that the density of dark matter is almost constant in time, resolves the tension between the Hubble constant measured locally and that inferred from CMB using the standard cosmology. Here's an equations, we can go through it. I will leave it up to you to read it later in the written form of it, but let me explain what's the reason for it. The reason is simple. In standard cosmology, the density of dark matter decreases with time, whereas the density of dark matter in Vedic cosmology is constant. As a result, if you look at the present time, the density of dark matter should be higher than that predicted by standard cosmology. And if you plug that into the calculation of the Hubble's parameter, because the density of dark matter is higher than that extrapolated by standard cosmology from CMB, it would turn out that it would predict a Hubble's constant value which is roughly about 15% higher than that inferred by standard cosmology from using the CMB. That's the last slide as far as this part of the discussion is concerned. I'll be discussing tomorrow, or in a later paper, a model based on the Vedic cosmology that answers a number of outstanding issues, problems, or questions in standard cosmology. that does not require inflation, nor does it undergo a contraction, as most of the cyclic models do. So with that, I will end. And if you have any questions, please email them to me.